Hi all, welcome to Clear and Concise. Let's have a look at this question. Two particles A and B are moving in a straight line as shown here in the figure, having velocities of approach VA and VB. Generally, we assume VA is greater than VB in order to facilitate the collision between these two particles. Now, after collision, the separation velocities are VA dash and VB dash. Now, we need to find the coefficient of restitution E. When these two bodies are moving with velocities VA and VB, after some time they will come into contact. Let's assume the time at the initiation of contact is T naught. After initiation of contact, there will be a momentum transfer between particles A and B, which gives rise to impulsive forces. So these impulsive forces will cause the deformation in the particles A and B. Deformation in the particles A and B. The deformation gradually increases with the contact area. So contact area gradually increases during the collision. It attains some maximum value at time t1. Let's assume at this point of time the area of contact is maximum and the deformation is also maximum. The period of this period, so from the initiation of contact to attaining the maximum deformation or maximum area of contact, it is called period of deformation. After this point, after attaining maximum deformation or maximum area of contact, then these two bodies slowly tend to move away from each other. So during this phenomena, the area of contact gradually reduces. And they are just away. They are just about to separate. The area of contact gradually reduces over the time period, and when they are about to separate, let's assume time is t2. So this duration from maximum deformation or maximum area of contact to the point where they are about to separate is called period of restoration period. Here the contact area, from this point to this point, the contact area gradually reduces and they are now about to separate. At this point the velocities are VA dash and VB dash. When they attains the maximum deformation, when the area of contact is maximum, they both move with the common velocity of u. So at t1, at the point t1, the velocity is u. They both have common velocity of u. Now, so we have two periods. One is deformation period and other one is restoration period. The impulsive forces acting in deformation period are Fd and restoration period are Fr on both bodies, equal and opposite. Now let's find the forces. The deformation force on the particle A is integration of T0 to T1. This is the period of deformation. Fd, impulsive force during deformation, times dt is equals to change in momentum, that is ma times va minus u. This is the initial velocity at time t0 and velocity at time t1 is u. This is the change in momentum during the deformation period. Similarly, for particle B, it is equals to t0 to t1 Fd times dt, that is equals to change in momentum in the particle B, that is mb times u minus vb. So these two are equal and opposite. Okay, similarly, finding the restoration force, that is from t1 to t2, the impulsive force is Fr times dt, that is equal to change in momentum ma times u minus va dash. This is separation velocity of particle A. Similarly, for B, integration of t1 to t2 Fr times dt, impulsive force in the restoration period, that is equals to change in momentum in the particle B during this period, that is vb dash minus u. Ratio of restoration impulsive forces to deformation impulsive forces, that is equals to, let's assume for part A first. So restoration forces are ma times u minus va dash divided by ma times this one here, ma times va minus u. So ma gets cancelled. We will be having u minus va dash by va minus u. Similarly, for particle B, if we write, we will be having, so Fr is vb dash minus u divided by Fd, that is this one, u minus vb. These two are equal. Okay, these two are equal. Now if we add these two, let's say u minus va dash plus, if we add these two, that is vb dash minus u divided by, similarly, va minus u plus u minus vb plus u minus u, here also plus u minus u, you will be having vb dash minus va dash divided by va minus vb. We have added here because if these two ratios are equal, then the ratios of their sums are also should be equal. So by using that, we have obtained this one. So from this we have obtained the coefficient of restitution E. So coefficient of restitution E is equals to the ratio of separation velocities vb dash minus va dash divided by approach velocities va minus vb. So it is the ratio of difference between separation velocities to approach velocities. So E value varies between 0 to 1. E value varies between 0 to 1. When E is equals to 0, the impact is perfectly plastic. Perfectly plastic. When E is equals to 1, impact is perfectly elastic. Perfectly elastic. So the correct answer for this question is VB dash minus VA dash divided by VA minus VB, option B.